Okay, we are now on to video 2. Sorry about that. This computer doesn't have the Pro version like my old computer does. So, next is a single replacement reaction. So here we have our metal, gallium, and cesium, which is also a metal, which is on your formative assessment. So we need to use our activity series here. And so cesium has to be higher than gallium on the activity series. So let's find cesium. I don't see it. And gallium. And neither one of them are on there. So that means the reaction's not going to occur. Okay, so there's no reaction. Can't determine it. Okay. Our last one, we have methane with oxygen. This is going to be a combustion reaction. Our products are going to be CO2 and H2O. We're going to go ahead and double that hydrocarbon right off the bat. We know that methane is a gas, oxygen is a gas, carbon dioxide is a gas, and water is a liquid. So we have 2 carbons on this side, we're going to have 2 carbons on this side, 8 hydrogen here. So we're going to put 4 there, so it gives us 8 hydrogen, so that's 4, and 4 is 8, so let's put 4 there. Now we can go ahead and divide this all by 2. I'll change my pen color. So that's 1, 2, 1, 2. All done there. Okay. Now we're going to go ahead and use this table to correctly write the formula. The products and the reactants, observing all diatomic molecules, ionic compounds, covalent bonds, then balance each equation on each side so that there's the same amount of atoms. Name the type of equation, write the states of matter for each element. And we're going to write the complete ionic equation and the net ionic equation. So the first type of reaction, we have nitric acid and we have iron hydroxide. So you can either put double replacement, I know that, or neutralization. Okay, it can be either one of those. We're going to write our chemical reaction. So remember, nitric acid, so there's always an H out front, and that's going to have a +1 charge. It ends in ic, so I know the polyatomic ion has to be ATE, so that's nitrate, which is going to be NO3 with a -1 charge. When you crisscross, we are A-OK there. So then we're going to add it to iron 2 hydroxide, so FeOH2, and we are going to get the products of, this is going to move here, this is going to move there. So we get HOH +1 charge, -1 charge, plus Fe, which is a +2 charge. I know that because of this right here, it tells me the charge of iron, and nitrate, NO3, with a -1 charge. So crisscross applesauce, we get 2. Okay, now I have to look at our solubility rules. Acids are always aqueous, so we have an aqueous here. This acid is this is a base, so that's aqueous. Water is a liquid, and nitrates, if we look at our solubility rules here, right here, nitrates right here are soluble, so we know that that nitrate is soluble, so that's going to be aqueous. Okay, now we can go ahead and balance it. 1 hydrogen on this side, nitrate, I have 1, iron, I have 1, hydroxide, I have 2, hydrogen, I have 1, hydroxide, I have 1, Fe, I have 1, NO3, I have 2. Remember, these tell you how many you have. So nitrate, I have 2 on this side and only 1 on this side. Hydroxides, I have 2, so I'm going to go ahead and put a 2 here, so that's going to be 2 hydrogens. Now 2 hydroxides, put a 2 out front here, 2 hydrogens, and 2 nitrates. Now we are completely balanced, so it's ready to go. So you can go ahead and write that down here if you would like. 2HNO3, so it's not as sloppy, aqueous, plus FeOH2, that's aqueous, produces 2HOH plus FeNO3, 2 aqueous. Now we're going to do our complete ionic equation. That's when we're going to separate it and make sure that we include our coefficients, our charge, and our states of matter. So we're going to do 2 hydrogens with a +1 charge, and that's aqueous, plus 2 nitrates, the -1 charge, and that's aqueous, plus Fe plus 2 charge, and that's aqueous, plus 2 OHs, -1 charge, and that's aqueous, produces, okay, now we have, oh, I didn't do the state of matter for water. Hopefully you know that's liquid. So water is a liquid. Remember, we can only break it apart if this is aqueous. That's not aqueous, that's a liquid. So we cannot break water apart. So it's going to stay 2HOH plus, we're going to have, how many Fe's? 1 Fe. Fe plus 2 charge, and that's aqueous, plus our 2 NO3s, -1 charge, and that's aqueous. Okay, so our next step before we get to the net ionic equations, we have to cross off our spectator ions. Remember, spectator ions occur on both sides, and they have to be the same number, same state of matter, and the same charge. So do we have any? We have 2 H's on this side. Do we have any H's on this side? Nope. Okay, we have 2 NO3s that are -1 charge aqueous. Look at that. We have 1 on the left, 1 on the right. So we're going to cancel these out. Then we look at iron. We have 2 on this side plus 2 on this side. Here we go. We can cancel those out. And 2 OHs. We don't have any of that. So there we go. So now we can write our net ionic. I'm going to do that one in green. So we have 2H plus aqueous plus 2OH -1 charge aqueous produce 2HOH liquid. And that is all it. That is all it. I'm actually looking at the tests right now. So those of you that are watching the video are going to get a little bit extra here. Make sure you really look over that vocabulary. All of that vocabulary that's on there. There's 5 vocabulary words from those, I think 10 that I put on here. Make sure you know how to balance. Combustion reactions are always CO2 and H2O. Make sure you know how to use that solubility chart and that activity series. There are direct problems that work with that. There is only one net ionic equation. You only have to do one of those. But there are quite a few for predicting the products, telling me if it's solid, liquid, gas, or aqueous, and there's a lot of points there. Just by knowing the states of matter too. So make sure you really look at those solubility rules as well. I hope you have a great night. If you have any questions, please come see me during win time.